Hi everyone, I'm Cindy and I'm a PM on the SDN team alongside Kyle, who you may have seen in our other videos. Today I'm going to cover public preview for SDN on Azure Local, so let's go ahead and get started. Before we jump into public preview, I wanted to briefly review the main features that we offer with SDN. There's 4 different buckets when we look at Microsoft SDN all up. There's network security, load balancing, virtual networks, and connectivity services. When it comes to network security, one of our promises with SDN is secure by default virtual machines, whether they're Windows Server or Azure Local VMs, and we do that a few different ways. One is network security groups, so just like what's available inside of public Azure, we bring those same network security groups to the edge, and then we also bring in tag-based segmentation, where imagine you have a junior admin at one of the sites who might not be as familiar with network constructs, such as what's the subnet, what's the CIDR range, what's the IP that I want to use, etc. And so tag-based segmentation is really a way of using key value pairs so that you or that junior admin can use simple self-explanatory labels to associate network security groups and VMs for access control. For example, the key could be virtual machine and the value could be SQL. So you would take that tag and you would apply it to a network security group rule, and then you would also apply that to an individual VM NIC or an individual subnet, whether that's a logical network subnet or a virtual network subnet. And just to be clear on what it is to be an SDN logical network versus an SDN virtual network, an SDN logical network is just a VLAN in your data center. So imagine you're on this journey to onboard to SDN, but you really want to get the VM security and microsegmentation landed. You can bring in network controller and immediately you can now apply network security groups or tag-based segmentation to your VMs that are still sitting on VLANs in your data center. So it's a really nice way for customers to transition into SDN and see our value proposition of the security piece. And then all of those are backed by our flow logs. So on every SDN deployment, we have east-west flow logs of your network security groups. We take those and we write them out to a local file, and then you have the ability to take that local file and upload it to an Azure blob. And for a lot of our customers, they want to take these flow logs and store them for compliance reasons. So those flow logs are fully exportable, and you can also use whatever tool you wish to explore those flow logs. They're in a similar format as Azure Network Watcher flow logs, so you could use Power BI, you could put them into a Custo database, etc. And now as we move into load balancing is a way that we provide a few different capabilities. One is, at its most basic, an L4 load balancer. So you have 2 VMs with an application and you want to do load balancing between those applications. The second and third capabilities that we offer with load balancing are inbound and outbound NAT. So you can imagine you have a collection of virtual machines that are sitting on a virtual network, just like inside of Azure. And of course, that virtual network is fully isolated. There's no traffic in or traffic out of it. And you can use an inbound NAT to provide a jump box for getting into your virtual network. So you would use a single public IP, configure inbound NAT, hit that jump box that's in the virtual network, and then you can secure the jump box with network security groups so that it can only go out and talk to different machines within that virtual network. The other big piece here is outbound NAT. So say you have a collection of virtual machines that need to access the internet. You can use a single public IP for your VMs that are sitting in a virtual network to communicate out to the internet or even out to the data center if you so choose. You can take a public IP and you can also assign that to an individual VM. So you can give short-term access and then you can just remove that public IP. So again, all very similar to public Azure. And as we move into virtual networks, this is fully isolated, bring your own virtual networks. You can have as many subnets as you wish, and we also give you the ability to use user-defined routes and NVAs. So if, for example, you wanted to use a different load balancer where maybe you didn't want to use our L4 load balancer, but you wanted to use an L7 load balancer instead, or maybe you wanted to use a security appliance and the security team has a requirement where any traffic that's going to leave this virtual network must go through the specific security appliance. You can do all of that with NVAs or network virtual appliances. So as long as it's supported in Hyper-V, you can use that on Microsoft SDN. And similarly, user-defined routes just means you can put a default route to route all the traffic up to that NVA and then let the NVA perform smart routing choices for you. One of the final pieces here is quality of service policies, where you can set QoS policies to ensure that no VM is starving another VM from the network side. And last but not least is our connectivity services. So with our connectivity services, we have gateways, and we have 3 different types of gateways to get out of a virtual network. One is an IPsec. So with a site-to-site, you want to ensure that it's secure communication. A GRE is really good if you already have an existing MPLS and you don't need to worry about security. You could simply stand up a GRE tunnel. And then the last, which is the most used by our customers, is just an L3 gateway. And what this is we basically take all of the traffic that's within the virtual network, and we will go out through the gateway, through a special IP compartment, and then we terminate on a VLAN that's in the data center. And once we terminate on that VLAN, you can route that traffic however you wish. We don't get in the way once it moves out of the L3 gateway. And this is really useful for when you may need to access Active Directory, DNS, file share services, etc. outside of the virtual network. Now, we do have customers where if they need to communicate with multiple clusters, you can use an L3 gateway connection on each cluster to actually jump to the next cluster for SDN. And then the last piece here is hub and spoke. So similar to public Azure and following a cloud adoption framework or well-architected framework, we do support hub and spoke. And essentially what that means is you could build a hub virtual network. You could have an L3 gateway connection that sits inside of that hub. And then you can peer, say, 10, 20 virtual networks to that hub, and they can all share that single gateway connection. So you don't have to have a one-to-one mapping of a virtual network to a gateway. So these are some of the major features that we have in SDN, and hopefully this gives a better picture of what SDN offers at a high level. But if you want to learn more, please check out our other videos for more in-depth content about these features. And now onto public preview. So we released our public preview program this past June 2025, and I just want to touch on some of the main capabilities that we're bringing in and supporting for public preview. The first is network controller running as a failover cluster service. So as we already quickly covered, network controller is our control plane, or I like to call it the brains of SDN. And with SDN enabled by Arc, we are delivering network controller as a failover cluster service so that it's fully managed for deployment. No need for VMs, no need for worrying about patch and update since it's running on the host, and deployment time is now reduced down to 5 to 10 minutes. And with network controller deployed, there's a few distinct features that we light up that are critical for a more robust security story. One is that you'll gain Arc-managed logical networks, which again are just your VLANs in your data center that you're already using today, and we program those into network controller. And then a key security requirement to ensure that no VM is left behind is network security groups. So once SDN is deployed, you can use the Azure Portal to deploy network security groups, attach rules to those, and you can also do default network policies on your VMs as well, which means that you're able to secure your VMs and ensure that they stay secured by default before the VM is even built. And essentially what we do is we block all inbound traffic to every one of your VMs except for well-known ports that you select when you're building a default network policy. So think RDP, HTTP, SSH, etc. And then we also allow all outbound traffic from that specific VM. And this is really critical when we talk about Arc VMs specifically, because we don't want to block connectivity for those Arc VMs that you're building. And then on top of that, we also have Arc-managed VM network interfaces, where the key benefit for network security groups is not only can you deploy this at your logical network subnet layer, where essentially any VM that gets attached to that logical network now filters through those NSGs, but you can also apply it at the individual VM NIC level as well. Like I just briefly touched upon, but want to dive a bit deeper into here, is the strong security posture that you'll gain with our network security groups. Network security groups are really just a 5-tuple access control list that we place on the virtual port inside of the virtual switch on every Azure local node. And network security groups allow you to apply granular network policies between applications and services and restrict access for workloads attached to traditional VLAN networks and overlay networks. You can apply NSGs to the vNICs on your VMs, but you can also apply it to your logical network. Again, is just your VLAN within your data center, so that every VM on that logical network automatically gets that network security group as well. This is what the UI looks like for NSGs in Azure Portal. And as you can see, the UI looks and feels very Azure consistent. So you can see there are inbound and outbound security rules. You can also see the VM network interfaces and logical networks that a NSG is associated with. So again, we tried to make this exactly like public Azure. While we've chatted about logical networks and network security groups, you might be asking, well, what about SDN virtual networks, load balancers, and gateways in Azure Local? Here, I just want to highlight some of the options you have with deployment, because while we're talking about Arc-managed SDN public preview, there's still a few different paths for customers who are on Azure Local in 2506. Of course, the first path is public preview, and that means that you can deploy a network controller on Failover cluster as a managed service using action plans. And that means you get network security groups, logical networks, and VM NICs. But if you're in public preview and we look at the non-supported SDN resources here, we still don't have virtual networks, load balancers, or VPN gateways yet. Those are coming and they're part of the roadmap for Azure Local, but we just don't have them today. So this is going to be the main differentiating factor for customers on whether they're going to come into the preview or whether they may deploy using traditional SDN, which just means you're deploying through on-prem management tools like Windows Admin Center or SDN Express, which is essentially our infrastructure as code engine. So if you are comfortable with PowerShell and you like doing repeatable deployments, then SDN Express is super easy to use. But if you're more comfortable with the GUI, then Windows Admin Center would be your tool of choice. And traditional SDN is still a relevant option here because you may need to still use virtual networks, load balancers, and gateways now and not wait until these are brought into Azure Local in the future. I just wanted to make sure that it's clear that we're not halting on the traditional SDN path, since both of these paths are still viable depending on what your requirements are. But regardless of what path you choose, we will make sure we migrate and hydrate you once everything comes into option 1 with Arc-managed SDN. Our goal here, of course, is to have virtual networks and load balancers and gateways eventually all available in option 1. And once those are fully lit up, then we will light up a migration path for anyone who goes into traditional SDN, and we will migrate all of those resources. Just keep in mind that there will be some downtime. We'll have to do this in a maintenance window because we will hydrate the entire stack over to this new version of Network Controller. Here we have a decision matrix helping you to decide whether to go down the Arc-managed SDN path or the traditional SDN path. With Arc-managed SDN, of course, it can be managed with Arc through Azure Portal. There is reduced host resource consumption because Network Controller runs on Failover cluster, and there is Azure Local VM support as well. However, it does not support all SDN resource types like virtual networks, load balancers, or gateways yet, since those will be added in future releases, and Arc-managed SDN does not support rack scale either. But on the other hand, going down the traditional SDN path with deployment through Windows Admin Center or SDN Express means that you're able to use the entire SDN stack, but you can't manage with Arc. It also requires some more host resource consumption since you'll need 3 additional VMs running Network Controller in Service Fabric cluster, and there is no Azure Local VM support, although rack scale is supported. If you decide to go down the Arc-managed SDN path, enabling Arc-managed SDN in Azure Local is super simple. This is a fully managed installation, so after deploying Azure Local, you'll just use the Add ECE Feature Action Plan to enable SDN public preview with a couple of mandatory parameters, such as using NC as the name and setting your SDN prefix, which is just the name of your Network Controller REST API DNS endpoint. And then defining the first and last MAC address of your custom pool are optional parameters, but are available for you to set if required. And then in terms of some considerations regarding public preview, we want to make sure that dynamic DNS updates are enabled. The NC REST name DNS record is pre-created before running the action plan, and also that the NC REST name is unique in Active Directory. It's also important to call out that once you're in public preview, there are no rollback or disable options. So once you enable Arc-managed SDN, you are essentially locked in. But we haven't seen any issues with public preview yet, so hopefully you won't run into any problems either. Some other things to point out are updates to newer Azure Local releases are supported, and enabling Arc-enabled SDN with existing Azure Local VMs and logical networks is also supported. And any existing logical networks you already have will automatically be hydrated into Network Controller. We are also hoping to GA very, very soon, and you can upgrade to GA from public preview, and there's no type of roadblock there where we're going to prevent you from being able to upgrade. GA is going to be exactly what's available in public preview, but the big piece with GA is that SDN will be enabled by default so that every customer will be automatically opted into SDN. You will have to go through Azure Portal to checkmark that you do not want to use security for your Azure Local VMs. But if you have a scenario where SDN doesn't work for you, we are also bringing in SDN optionality so that you can turn SDN off on a specific logical network. Great, so that about covers a high-level overview of our public preview program and deployment path. If you're interested in opting into public preview or have any questions about anything discussed in this video, please reach out to either me or Kyle, and we will be more than happy to help you. And finally, make sure to give us a like and subscribe so that you are up to date on all things SDN. Thank you so much for watching, and we will see you in the next video.